Welcome to the studio at African Utility Week. I am Nicolette Pomba van Zyl and I'm here with Stephan Padlewski from DuPont today. Welcome, Stephan. I'd like to start off with understanding the market in terms of global growth for PV, rooftop PV, and how does Africa compare with that global growth?
Okay, very good. As far as the global rooftop market, it's certainly the fastest growing segment globally. Probably account today for 40% of the installation globally, and then it depends upon the region. There are some more mature marketplaces versus other one. In Europe, for instance, the market penetration for rooftop exceeds 70%. So most of the PV installation are rooftop related. So Europe is a very mature, rooftop driven, where other marketplaces such as China, primarily driven by ground installations. Africa in general, the PV market is relatively new, and as you know, it started mostly on the ground installations. And it's still pretty much a ground market, ground-driven marketplaces. But we see the rooftop market segment growing extremely fast. Actually, it's the fastest growing market segments. So today it accounts for a very small portion of the installations, but what we foresee over the next 5 years, it will account for over 35% of the total market installations. And here we talk about Sub-Saharan Africa and South Africa in particular.
You mentioned ground and rooftop installations. Do you want to give a bit of an explanation of what are the differentialities in technology?
It's very simple. In a nutshell, you talk about very similar type of installations. Both would consist of PV modules. Now there are some differences between the two, the way we see it from a reliability, durability standpoint. But in essence, you deal with the PV panels, you deal with the cabling, you have to interconnect them with a mounting structure that is different, whether you're on a ground installation versus a rooftop installation, and then you have to convert the DC power into an AC power with inverters. So in a nutshell, you deal with a very similar type of installations from a component listing standpoint. Now there are differences, of course, that you mentioned. The one is the ground installation are typically very large installations. You deal with the megawatts, dozens of megawatts of systems, as those you see in these countries, the 50 megs and plus type of installations. On the rooftop, you deal, because of the constraint on the real estate, you deal with much smaller system. And that's one of the beauty of PV system technologies, because it's scalable. You can go anywhere from small to very large systems. So the large are for the ground, and the smaller one are typically for the rooftop systems.
Right. And in terms of long-term sustainability of rooftop PV, what considerations need to be taken in there?
Okay, so one thing important to remember is PV system, the technology is designed to withstand, to produce power for over 20 years, 25 in fact. Now the expectation is for PV system to operate up to 30 years. So that obviously creates a lot of constraints to the component level. They have to age and they have to endure very different type of stress level. On the ground, the stress is primarily driven by the irradiations, the UV irradiations coming from the backside of the panel. So you have a lot of UV, you have a lot of thermal stresses, but you also do have a lot of UV irradiations coming back, reflected back from the ground. So that's one aspect to always consider from the reliability and durability standpoint. On the rooftop, it's all about thermal stress. Panels deploy, a PV module deployed in the rooftop is typically mounted very closely to the rooftop structures with a very limited air gap. So the temperature builds up at the module level and it generates a lot of stress. So that basically calls for a very different type of solutions, obviously, to handle the stress level that exists on the rooftop.
And can a PV rooftop be installed on any building, any large space on top of a building? Because we have a lot of buildings that are over 50 years. Does that building need to go through some sort of retrofit?
Well, it depends upon the building. I mean, PV is scalable. It can go from anywhere from small to large. So technically, you can go after small residential rooftop structures to a large, say, commercial building, such as the one that is deploy over our heads right there. Now, you mentioned about all building structures. So one key consideration is obviously the orientation of the building. You have to face north, obviously, from here. You know, the rooftop pitch has to face the north to maximize the power output. But you also have to take into consideration, so the orientation is key, but also the building structure is essential. So because you have a weight load factors to consider. So weight is typically a constraining factor, especially in the very old buildings. So you have always to look for solutions that are compatible with the building structures. But beside that, there are not much other consideration to take into account.
A lot of people that always want to go the rooftop PV way have one question. What about feed-in tariffs? What are the challenges there and the potential solutions?
Okay, I mean, one of the key challenges for the PV industry is, like any other renewables, is to compete on a cost basis versus incumbent source of energies. You know, it's all about energy, producing energy cost effectively. So one of the key metrics to take into account is what we call the LCOE, the levelized cost of energies. So today the cost of energies for PVs is competitive in most locations around the globe, and it starts becoming competitive as well in South Africa. So from a cost standpoint, if you are off-taken user of power, you can produce electricity using a PV system cost effectively, cheaper than what you can buy or purchase from the grid. So there is the notion of tariffication, a special tariffication is important to jumpstart the process, to ease the newcomers to invest into the technology. But long term, it's not necessary to handle to utilize a feed-in tariff technology. Now, what is important though, as most of the systems are grid connected, is to allow what we call the net metering technologies. You know, so you produce PVs is an intermittent source of energy. So you produce power during the daylight, but not so much during the night, obviously. So here you rely upon the grid to provide the electricity. So what is important to accelerate the adoption, this is especially true in South Africa, for the governments to consider is the net metering possibilities. So whenever you produce more power than what you use, the grid should be able to take it. And in opposite, if you consume more than what you are producing, then you take it back from the grid system. So that's really what is needed, you know, to enhance and to accelerate the adoption of PVs for on a rooftop application.
This is something that takes place in Europe?
In Europe, pretty much, yes. That's pretty much one aspect that helps stimulate the demand markets to bring flexibilities to the investors and the off-takers. And that's absolutely something needed, and we think will be needed as well in South Africa in the early days.
Rooftop PV for commercial buildings makes absolute sense. But what about residential? Individuals that want to look at investing in rooftop PV. We are investing in geysers, hot water cylinders connected to solar, but what about taking it the route further?
I think the same logic applies whether you run a business where you need some access to cheap electricity, or whether you are a homeowner where you still need to have access to cheap and a constant power source as well, which is another issue in these countries. To compensate for some grid instability issues or some power supply issues that may occur. So having your own system on your own roofs to produce power that can be on the top of that cost effective, I mean, it can perfectly apply to homeowners into the residential market. So it makes perfectly sense to utilize PV also in this particular segment.
And lastly, you do a lot of research into the market. What is the most interesting thing that you have found?
Okay, on the rooftop, talking about the rooftop, what drives the market is the need for higher efficiency panels. So from a technology standpoint, what the installers and investors, whether you're a homeowner or whether you run a business, you want to deploy a PV system on your rooftop, is to deploy higher efficiency panels. Efficiency is important because it helps packing more power output within a limited surface structures. The second one, very important, that show up as a very strong demand from the market is the need for higher quality products. There is a higher risk when you expose a PV panel close to a very high value asset, such as the buildings, that things can go wrong. PV operates at 1,000 volts, so it's an electrical device. So you want to make absolutely sure that that the panel and the component operates safely, durably and reliably over its expected lifetime. So that's one thing that came up very high on the demands from the market.
Thank you very much for watching.